It's Friday, and today we're going to be talking about simplifying radical expressions that have some variables inside of it. I do have 22 problems. I'm just going to try to get through as many as I can. You don't probably need to see all 22, but it never hurts, and it'll still just be 15 minutes. All right, so we have reduced radicals before, but all we're doing now is we're including an x. So again, you can do it old school way and break it down. This means x times x. Always, when there's no index, it's understood index of 2, so I'm looking for groups of size 2. So I have 2 x's, so my answer is x. Okay, here I have 3 x's, looking for groups of size 2, so I can take out a group of x's, leaving just 1 x on the inside. But also, I don't want to do this every time. I don't want to write out however many x's there happen to be. So what you're going to do is you're going to say, how many times does 2 go into 3, how many times does the index go into the exponent, and what's the remainder? Well, 2 goes into 3 one whole time with 1 remainder. That's it. All right, we should hopefully know the square root of 9 is 3, but I'm going to break it down. That's 3 and 3. And of course, if you want to write it out, you always can. But again, group size 2, so there's 2 3's. How many groups of size 2 can I pull out for x's? Well, I can pull out 2 of those, which means I have x squared, leaving on the inside no numbers because I pulled out everybody, and 1 x left over. Again, 2 goes into 5, 2 whole times with 1 remainder. Okay, I definitely am not going to write out 21 a's there. So 104, I know that half of 104 is 52. I know half of 52 is 26. I know half of 26 is 13. So looking for groups of size, again, just 2. And we are going to do cube root and fourth root and fifth root and all that jazz. So you do need to pay attention to the index every single time. So groups of size 2, well, I can take out this set of 2's, but no one else has any partners. So whenever I do these problems and I know it's not going to be perfect, I always write my answer on the outside. I skip however many variables I have, so A, B, C, whatever, and then I go straight on the inside and push these guys back together. 2 and 13, you're going to multiply those guys back together, and they're still going to turn back into that 26 on the inside. So don't forget, if you don't have enough to make your pair or trio or whatever, you just push it back on the inside. Okay, and then I don't want to write out 21a, so I'm going to say 2 goes into 21 how many times? Well, 2 times 10 is 21. I'm sorry, 2 times 10 is 20, with 1 left over is 21. And that's it. That's your answer. Okay, square root of 16, I'm going to break that down to 4 and 4. I'm not going to break it down further to pairs of 2 because in the end, I've got a pair of 4s. I'm done. Okay, and then if you want to break this down, you can, but I don't want to because I just say 2 goes into 4 how many times. All right, so square root of 16 is 4. There's no number on the inside, so I don't need to skip any space. 2 goes into 4 2 whole times because I'm able to pull out 2 groups, and that's it. Final answer. Okay, moving on over here, 18 is 2 times 9, 9 is 3 times 3, and I do have x's and y's, and you will have several variables. We can see down here we got 3, so just take it piece by piece. Again, I'm doing index 2, so looking for groups of size 2. Well, I have 2 3's, so I'll go ahead and put a 3 there. I'm going to skip x and y, so skip room for x, skip room for y, and then on the inside I'm stuck with just a 2. I recommend taking care of the number entirely, or you're going to forget, when you start doing variables, you're just going to forget about that 2 entirely. So pull out your group, look at your remainder, put them inside, then go do your x. Okay, well 2 goes into 2 one whole time with no remainder, because I have 2 x's, I take them all out. 2 goes into 5 2 times with 1 remainder, because there's a pair, this guy is solo. Also, very common mistake that I see, people will put this exponent very close to this index, which in this case is a 2, who cares, but I want to make sure it's y squared, not y and then square root 2y. So make sure that is very clearly attached to that guy. All right, moving on down. This one, 96x cubed and 3x to the 5th. Don't forget we have that inside, outside rule. So these guys are all inside numbers. You can actually just kind of divide within those radicals. So, and we'll talk about rationalizing on Monday or Tuesday, whichever day it comes up. So 96 divided by 3, hopefully you know, is 32. Okay, and that's on top, right? So 96 divided by 3 is 32. But then this guy is bottom heavy. So when I subtract, I'm actually going to cross out all 3 x's on top and leave 2 x's on bottom. So that guy actually ends up being bottom heavy. Or you can say 3 minus 5 is negative 2, and that goes in the bottom. So when you're dividing, whether it's inside, inside, or outside, outside, make sure you have the locations secure. Okay, 32 is 2 times 16. 16 is 4 times 4. And I'm not going to break it down. Once I see a pair, I'm not going to break it down further, but you could obviously break down 2 and 2 and 2 and 2. All right, and then x squared is, I surely don't need to break it down, but just showing you x and x. So doing the top by itself, I have a pair of 4s, and I have a 2 left over. So the top is 4 root 2. And you don't need to write the 2 index if it's just a regular old square root. Okay, and on the bottom, the square root of x squared is just x. The square root of x squared, and that's an inverse operation. When we do cube root of x cubed and fourth root of x to the fourth, that's also an inverse operation. Okay, so now let's do some that have some stuff on the outside. Literally, you just make sure you're more careful and just bring this guy down. So I'm going to break down 18 to be 2 and 9. 9 is 3 and 3. So I'm going to bring this 2 down, and then I'm going to just do my numbers. So I can pull out a pair of 3s. I'm going to skip room for A and B, boom, boom. And then I'm going to put my 2 inside. So I've taken care of my numbers entirely. If I had any other variables to bring down on the outside, I just bring those with me. Okay, and then don't forget, I'm looking at the index here. So 2 goes into 12 how many times? Well, it goes in 6 times. If I were to, those are all A's. If I were to group this, I have 1, 2, 3, 4, 5, 6 groups of 2. Okay, and then same thing for B. 2 goes into 13 6 times as well, but that's only 12, so I need 1 extra guy left over. Okay, and then just clean it up. If you have any other variables on the outside, just bring them with you. So 2 times 3 is 6, and there's no other A or B or whatever to multiply. So A to the 6th, B to the 6th, skip a little bit of space so that you don't accidentally make the exponent look like the index, and 2B. All right, I'm actually going to go ahead and change this problem while I'm here just because I want to make it a little more creative. I'm going to put an X on there. So this problem is now 6X, and I'll change that on your notes if you happen to print them out. Okay, so I'm going to go ahead and bring this 6 and this X down so I don't forget about it. All right, 50 is 2 and 25. 25 is 5 and 5. So doing the numbers, I can pull out a pair of 5s, and I'm going to skip X, Y, Z, and go on the inside and put that 2 on the inside there. Okay, and then I'm going to go through and do each variable. Again, looking at just the index. 2 goes into 2 one whole time, so I take out all my X's. 2 goes into 1 no times. There's not enough Y's to even bring anybody out, so he just goes straight back in. And 2 goes into 3 one whole time with 1 remainder. So that was Z, Z, Z. I pulled out 1 group and I left 1 on the inside. And then they're all on the outside, so just multiply. So now I have 6 times 5, which is a 30. I have X times X, which is X squared. And I have a Z. Skip a little bit of space so you don't accidentally push these things too close together. And then on the inside, I have 2Y and a Z. So very, very easy concept. I really hope it's not super challenging. We're going to go ahead and go on the back side, and we're just going to change the index number. The rules don't change. Everything's exactly the same. We're just going to do cube root, fourth root, fifth root. All right, we'll just get through as many as we can. I talk fast enough. We probably could get through all of them, but we'll just have to see. All right, so simplify the expressions completely. Literally just pay attention to the index. That's all I got to do. If it's a cube root, look for groups of size 3. If it's a fourth or fifth or whatever, then look for those group sizes. All right, the exact same process. I break it down, look for group size 3. Well, 3 goes into 3 one whole time. My answers are literally just X. Okay, and I'll show you again the long way, but it's the same process. Okay, look for groups of size 3, so I can pull out a group of X's, leaving on the inside, do not forget your index. Most common mistake is students turn this cube root into a square root. Do not forget your index. Leaving 2 guys on the inside, so x squared. Also, 3 goes into 5 one whole time with the remainder of 2. Done. All right, and then same thing with numbers. We're just going to break it down. So 2 half of 128 is 64. Half of 64 is 32. Half of 32 is 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. Hopefully that's correct. Looking for groups of size 3, so just pull out this group here, and this guy is going to be solo. So I'm pulling out a 2 and a 2, so I'll go ahead and just write it out. Don't forget your index and the 2 on the inside. But a 2 and a 2, they're both on the outside now, so my answer is 4 cube root 2. All right, moving on down. Same exact process again, and you see that we're getting ready to do 4th and 5th and 6th roots down here at the bottom. So 24, half of 24 is 12, half of 12 is 6, half of 6 is 3. Looking for groups of size 3, so I can pull out all of these 2's. I'm going to go ahead and skip space for my x, and I'm going to go ahead and take care of this 3. Do not forget your index number on that radical. If you change it from a cube root to a square root, it's obviously wrong, so make sure you're very careful. All right, and then so the number's taken care of. 3 goes into 6. How many times? 2 whole times. If I were to put 6 dots, group of size 3, group of size 3. There it is. All right, 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. Groups of size 3, so I'm taking out a pair of 3's. Well, not a pair of 3's, I guess a group of 3's. Skipping space for my y, going straight to my index, putting a 3 there, and then putting that 2 on the inside. And 3 goes into 4 how many times? 1 whole time with 1 remainder. All right, 125, that's 5 times 25. 25 is 5 times 5. So my number is done. Groups of size 3, that's everybody. Okay, nobody on the inside, so I don't need to actually go skip a bunch of space. I'm just going to go 3 goes into 7, 2 times, because that's 6. Skip a little space, B and C, put my cube root on there. So 3 goes into 7, 2 whole times with 1 remainder. 3 goes into 9, 3 whole times, because 3 times 3 is 9. 3 goes into 1, nada. So there's no C value on the outside, so this guy is just hanging out solo on the inside. All right, moving on down. Again, we'll try to get as many as we can. 4th root, exact same rules, just do the math. 2, half of 48 is 24, half of 24 is 12, half of 12 is 6, half of 6 is 3. Okay, groups of size 4, don't forget what you're doing there, pulling out a 2. Skipping space for my x, putting my 4th root on there, I got a 3 on the inside. 4 goes into 6, 1 whole time, with the remainder of 2. 5th root, 96. Half of 96 is 48, half of 48 is 24, half of 24 is 12, half of 12 is 6, half of 6 is 3. Looking for groups of size 5. 1, 2, 3, 4, 5. Cool, that's everybody. Pull out that entire 2, skip room for my y. Don't forget your index, put that 3 on the inside. Number is done. 5 goes into 10, how many times? 2 full times. No remainder. I hope I'm not going too fast, but I mean, it's the same. I want to get down here to this end guy. All right, 162. Half of 162 is 81. No, just kidding. 81 is 9 times 9, and that's a 3, and that's a 3, and that's a 3, and that's a 3. Looking for 4 guys. Well, look, there they are. There's a 3. Skip space for x. Boom, bitty boom. Don't forget this guy on the inside. 4 goes into 16. Man, these problems are easy peasy. Lemon squeezy. And I'm also double checking the key to make sure I don't mess up. Okay, less than a minute. Okay, we're going to skip these guys. Same deal. I want to go over this n stuff. Okay, looking for groups of size n. If I were to write out 9 a bunch of times, I would have n of them. So my answer is just 9. You can only pull out a number if it has an n. Here, inside, you get nth root of 15x to the 6th. N doesn't go into 15 or into 6. That's terribly written, so I'm just going to write it one more time. You can only pull out stuff if it has an n. So if I had, in the end, nth root of 15x to the n, Then I could pull out an n and I'd still be left with that. Oh my word, the pressure's getting to me. That there. All right, we did it, and go ahead and do your homework.